All right, hello. My name is Jennifer Lambert. I am a teacher at the Mary Lyon School. I have included my email down below. It's jlambert@bostonpublicschools.org. Please feel free to reach out to me at any point during the school year if you have any questions or concerns. In the screencast, I will be talking to you about Investigation 1 called Here to There. This investigation is 5 sessions or 1 week. And the main idea that you want students to understand is what is motion. So the 3 objectives for this investigation is actually taken directly from the student learning outcomes, which is what you can find on the BPS Science Weebly page, which I discussed in the overview. Again, if you go to bpsscience.weebly.com and you click on the student learning outcomes and pacing guidance calendars, it will tell you how long this investigation should take in the main concepts of this investigation. It will also tell you if there's any common writing assignments that are attached to this. It just is a very good wealth of information. So in this investigation, students are going to be calculating distance using the distance equation, and they will actually come up with the distance equation through doing some hands-on activities. They'll be able to measure the distance in standard metric units, both using a worksheet and using real-life data. They will observe and describe an object's motion in terms of change of position. They'll be able to explain how to use a reference point to determine the distance moved by an object. And they will also be using tools to gather data and mathematics to organize data. And if you are wondering what the PS11 or PS12 means, this is just the actual standard that they're talking about. So this is Physical Science Standard 12. The next page, when you open your teacher's edition, behind the Investigation 1 tab will be this page. So in addition to the student learning outcome page put out by BPS, this also will go through what your objectives are. So here they tell you what your overall goal is. They tell you what the science content is. They tell you what the students will get out of conducting the experiments. And they will also say, what are the main building explanations? So what do the students need to know this investigation that will build on to next investigation? So if you see here, they're talking about being able to describe an object's motion in terms of change in position. That's something they will be going back to the entire unit of force and motion. And they also need to be able to use a reference point. The next page in your teacher's guide breaks it down even further. So you'll see here that there's part 1, part 2, and part 3. So this investigation is broken into 3 main ideas. In part 1, they're going to fly air trolleys. And here's where they're actually going to be able to give you the definition of motion. Motion is a change of position. The next part is they'll be collecting data and making graphs. And in the third part, they will be continuing to do some practice. This next page, I just wanted to show you that in your teacher's edition, there's also this second page, which is really helpful, especially as you're getting started. So this line is showing you what do you need to prepare in advance for your class. This is always very good to look at the day before because you don't want to get into your class and then realize, oh, you needed to do all these things. And then on the right side is just a step-by-step kind of overview of what the students are going to be doing in that class. So I sometimes use the step-by-step to also create my agenda. Now, this is what the students would see when they came into my classroom for this first day. So their learning goal at students will be able to gather ideas of what they already know about force and motion, and then they need to make their trolley move. That is their goal for the day. And then I'll show them what their agenda is, and we'll talk through it. So my quick write, I always start a new unit having students tell me what they already know. So this is activating prior knowledge. So I have picked out some of the key ideas that they will find in this entire unit, and I've just thrown it up there. Now this helps get students' ideas rolling, so they're not just staring at the page saying, I don't know what to do. Sometimes this overwhelms students because they're like, oh, I don't know anything. But then I always say, well, you're not supposed to know everything. If you did, you wouldn't necessarily be here. But it's also a really good formative assessment for me, so I can figure out where the students are starting this unit. And you will see some classes come in with much more knowledge than other classes do, and it's really important to know this. So I'll have them do this. They'll probably take about 5 minutes, and then we'll share some ideas. We'll not talk about any right or wrong ideas. We're just gathering information. Then the next task I'll ask them to do is to write a definition of motion without using the word move. And this always throws the students into a tizzy because they always think that motion is moving. And when I tell them they're not allowed to use the word move, it really pushes them to come up with the definition that motion is the act of changing position. And that is the vocabulary definition in this investigation. Here is the air trolley construction. Now, you might decide that you want the students to do this because it's practice following directions and following a procedure. I personally make the trolleys for them so we don't have to waste time in class doing it. I have done it both ways. I've decided that making it for them is a bit easier, and I've made them once, and now I keep them year to year. And the only thing that breaks from time to time is the straw, and you can just fix that. So it's a little bit of upfront work, but then you will save it for years to come. So my next step is I'm going to give them the air trolley, which looks like this little guy. And I'm going to give them a piece of string, which is a fishing string, and 2 chairs. And all I tell them to do is make their trolley move. This is slightly more open-ended than they talk you through the investigation, but it works and the students really like it. And once they have done that, I ask them what evidence that do they have that their trolley has moved. And what I'm looking for is that they say something like it's changed position. Because then we can talk about starting position and ending position. So we can talk about the idea that there's an XI, initial position, and an XF, ending position. And if they have started and ended, they have gone a distance. And those are all the key ideas of this investigation. That the students are finding out the information without you just telling it to them. The next thing I have the students do is I have them determine the distance here. So this brings up the idea of the importance of a reference point. So some students will say that this trolley has gone 85 centimeters. Some will say it's gone 75 centimeters. Some will get all confused and say it's gone 80 centimeters. The correct answer, of course, is 85 minus 10 is 75, or 75 minus 0 is 75. The idea comes up here that the reference point is very, very important, or it can skew your data. And it doesn't matter if you use the front or if you use the back, as long as you're consistent from one to one. And this is where we're starting to develop the distance equation. Part 2, students actually design their own experiment. So before this part, after their initial just checking things out, we talk about all the things that affected the trolley's motion. And they talk about the tightness of string, the type of string, the air trolley, the number of lines, the direction of lines. And this is actually what we end up using. And this is a really good way of explaining independent variables versus dependent variables and how to create a well-designed lesson. And what we end up doing is the students end up taking data. They do a series of 3 to 5 trials. So it's another really good opportunity to talk about the importance of collecting a lot of data. And then they actually graph class data. And this is an opportunity that you have to even talk about outliers in line of best fit. And this is part 3. And here you're again just kind of keying into these ideas of position, delta, motion, distance, reference point, and the equation for distance. So it asks them to show their math here. So if they haven't figured out the distance equation here, by the end of these road races, they should have it just by doing the math over and over and over again. And then the final is just the assessment, which we are going to run out of time to discuss.